Hey, thanks for joining me. Today we're going to classify numbers, and we're only going to classify numbers as natural numbers, whole numbers, integers, rational numbers, or irrational numbers. I want to show you the little cheat sheet I have here for all the different sets of numbers. And we're only talking about these first 5 natural numbers through irrational numbers. But here you can see kind of a little picture of what each set sort of looks like, and the nickname each one has. Natural numbers are nicknamed the N, set of N, W for whole numbers, Z for integers, so on and so forth. Okay, so you can hit pause if you want to jot that down in your notes. Now, back to our question. Since we are classifying with these 5, let me get my pen going here. These 5 different classifications, we want to write these down, and I want to kind of show you how they relate to each other. So I'm going to say natural numbers here, and then I'm going to say whole numbers, and then integers. I think I missed an E there. My E and my G is mixed together. Integers, rational, irrational. But now watch this. Natural numbers is this little tiny set. Whole numbers are natural numbers. No, I said that wrong. Natural numbers are in the set of whole numbers. And integers contain all the whole numbers and the natural numbers. And rational numbers contain all of the natural, whole, and integers. But irrational numbers has no overlap. Right? There's no overlap between the rational and the irrational. So when I put something in a category, if it's inside the circle for a particular category, it is that thing. So in other words, some of these numbers could be more than one thing. I'll show you how that works. Let's start with the first one, -5. Now I think you can see that that's an integer, because integers, the big deal with integers is that they have negative numbers. So -5 is definitely an integer. So it's in this integer circle. All right, but it's not inside the whole number circle, because whole numbers, remember, are all positive or 0, and natural numbers are all positive. So it's not a whole number or a natural number, but it is inside the rational number circle. So -5 is an integer. That's its base. Oops. That's its base. I just can't catch a break with my G's and my R, my E and my G there. Its basic classification is an integer, but it's also rational. Let me prove that another way. Can we write -5 as a fraction? Absolutely. That would be -5 over 1. So -5 over 1 equals -5, therefore we can write it as a rational number with an integer on top, -5, and an integer on the bottom, 1, and therefore it is a rational number. And in fact, there's lots of different ways we could write -5 as a fraction. So there you have it. There's the classification for -5. Now, what I like to do when I'm doing a question like that is I like to just do one at a time, and I like to go with the easiest one. So -5 seemed pretty easy to me, so I did that first. But what's the real easiest one up here? I think you'll probably say the same one I'm thinking of, which is whole numbers. the 0, which is a whole number. So the whole point of the whole, get it? The whole point of the whole number classification is it is the natural numbers plus the number 0. It's the first set of numbers that includes the number 0. So 0 is a whole number. Now, if the question said, what is the primary classification for 0, we would say, well, it's a whole number. But it is also an integer. It's on the integer list. And it is a rational number. Should we prove that? What's 0 thirds? Well, 0 thirds is 0. We can write 0 as a rational number, as a ratio of two integers. So there we have it. Okay, what about, so that's 2 down. What about that decimal there? That decimal's going to freak us out, and this one is definitely freaky because it is the, oops, lost my spot here, that negative 0.3 repeating. We have to know a little bit about repeating decimals here. I'll just say that you should, there's 2 things that you should put in your notes. We'll do this in blue here. So in your notes you should have 1/3 equals 0.3 repeating, and 2/3 equals 0.6 repeating. Okay, those are the most common repeating decimals. Those are the ones that, by far, the ones that you're going to see the most often. They're excellent examples of why we don't like to use decimal representations, right? Because if we divide by 2, you get 1/2 or 0.5. 0.5 is a decimal. It's perfectly fine. Everybody knows what that means. 0.5, 50 cents. But 0.3 repeating is really hard to write. It's really hard to get that, that repeating symbol on there. When you type it in your calculator, it's 0.33333 to the end of the page, at the end of the screen, and when you do 2/3 is 0.66667, right? They round up to 7. So it's just really awkward. But these are the 2 that you should kind of look for. And when you see a 0.3 repeating itself or a 0.6 repeating itself, you know that you've got some sort of a third there, a third or 2/3. Okay, so that's what we have going on here. That negative 0.3. We know that negative 0.3 is the same as negative 0.3 repeating, sorry, different than 0.3. 0.3 repeating is negative 1/3. And that is, well, that's a rational number. 1/3 is a rational number, and negative 1/3 is a rational number. So we'll say that's a rational number. Now, a couple of mistakes people make here. Is it an integer because it's negative? And remember, integers are negative. That's how the thinking goes. No. Integers can be negative or positive, but they cannot be fractions. They can't be a fraction other than a fraction with the denominator of 1. So an integer is a whole number. We like to say it's a whole number that's either positive or negative or 0. It cannot be a fraction with a denominator different than 1. So there's our only classification for negative 1/3 is rational number. It's only in the rational number circle. Okay. Whew, that one was a little bit more complicated than the others. Let's do the square root of 16. Now, this is another trick question, and I'm really glad we get to talk about this one, because the square root of 16 can be simplified. And that's the trick here. A lot of these are in a form that we could write in a different form. Well, most of them aren't, but we could definitely imagine a lot of different questions being asked where the trick is you just have to simplify it. And the square root of 16 is one of those numbers. Square root of 16 is 4. And we can get that on our calculator. It's always a good idea when you're kind of unfamiliar with square roots to just type on the calculator to check to see if they're rational or irrational straight up. The calculator could tell you that, because if it gives you a decimal with a long string of numbers, then you know it's probably irrational. And if it gives you just a whole number without a decimal, you know it's rational. So the square root of 16 is 4, and 4 goes in the category of natural number. So even though they gave us the number as the square root of 16, the square root of 16 is 4, and 4 is a natural number, so it is a square root of 16 is a natural number because it's 4. So the form it takes does not determine what, like the form we put it in doesn't determine. Like I could write it as 4 over 1, or I could write it as 8 over 2, and those would be rational representations of the number 4, but they're still the number 4, and so it's a natural number. So 4 is natural, which means it's also a whole number and an integer. There I go again, having trouble writing the word integer. Just don't want to put the E and the G together, and it is a rational number. Okay, well that's probably the end of the trick questions. The last one, we'll type it on our calculator, square root of 17, and we get some crazy number. It's going to be 4 point something, and it's going to go to the edge of the calculator screen. Let me give you one just real quick, this is for free, real quick way to tell or to think about rational and irrational numbers. And we'll just do a real quick list. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. So the square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, square root of 16 is 4, and the square root of 25 is 5. And we can keep on going with this list. You could make this list up. You could spend all day writing a list going as big as you want. But these numbers here on the left, 1, 4, 9, 16, 25, and so on, are called perfect squares. And the square roots of the perfect squares are 1, 2, 3, 4, 5, 6, 7, so on and so on. Which means that in between these numbers, we have other numbers, right? Between square root of 1, square root of 4, we have square root of 3, square root of 2, square root of 5, square root of 6, square root of 7, square root of 8, square root of 10 through 15, and there's our square root of 17 in between square root of 16 and square root of 25. If we have a number in between a perfect square, the square root of a number in between a perfect square, square root of 17, then we know that that is an irrational number, because the only rational numbers are the square roots of perfect squares. So then the irrational numbers are everything in between. So that's one way to think about this if you want. Thank you very much for watching. Have a great day.